If you've spent any time on social media recently, you've likely seen the alert, a claim that there is a 72. We are coordinating a planetary shield, a global effort to move from being passive targets to active observers of the solar system. The first rule of defense is simple. We cannot stop a threat that we cannot see. There is a major difference in how we track these objects. Rocky asteroids generally move in predictable loops, but comets, volatile, dirty snowballs, can travel twice as fast with trajectories that give us much less time to react. Our first line of defense is a network of telescopes like Linear and the Catalina Sky Survey. These joint projects scan the darkness to discover thousands of near-Earth objects every year. If something slips through the initial net, the Atlas system in Hawaii serves as a final alarm. It scans the entire sky twice every night, looking specifically for fast-moving objects that are already close to our atmosphere. This interconnected web of high-resolution cameras has reached a point where the majority of large, deep space threats can no longer catch us by surprise. Once an object is found, it's logged into a globally monitored risk list. Every object is categorized by its size, its potential impact date, and its calculated probability of hitting Earth. Apophis serves as a foundational case study for this process. When it was discovered in 2004, the initial data suggested a 2.7% chance of impact, high enough to cause global concern. The assessment is difficult because of gravitational keyholes. These are tiny pockets of space where Earth's gravity pulls a passing asteroid just enough to guarantee a future collision. But refined math proved Apophis will miss these keyholes entirely, dropping the impact risk to zero. But if the math confirms that an asteroid is on a collision course, what happens next? Our primary tool is the kinetic method. We launch a heavy spacecraft to physically ram the asteroid, nudging the massive rock into a safe orbit. This isn't just a theory. In 2022, NASA's DART mission successfully crashed a probe into a distant asteroid, proving we can successfully change an object's orbital period. For threats detected decades in advance, we could use a slow push. A spacecraft focuses solar energy on the asteroid's surface, vaporizing rock to create a natural gas vent. That vent acts like a small thruster, slowly pushing the asteroid off course. While nuclear options exist for massive threats, they remain a last resort. They are geographically restricted by international law and carry the risk of shattering one large threat into thousands of smaller, unpredictable pieces. With these tools, planetary defense is moving from theoretical physics to applied engineering. We now have the technology required to move celestial bodies. This brings us back to the fake 2038 panic. That 72% probability was part of a tabletop exercise, a drill where experts rehearsed these exact detection and deflection steps so they are ready for a real scenario. Even with these systems, small, localized meteors can still slip through. They are often too small to track until they hit our atmosphere, leaving streaks of light across the sky. When the Chelyabinsk meteor exploded over Russia in 2013, the shockwave shattered windows and caused injuries across the city. Events like this require local disaster management rather than deep space intervention. To catch these smaller objects even earlier, NASA is preparing to launch the NEO Surveyor, a space-based telescope that will hunt for asteroids from the vacuum of space, far away from the interference of our atmosphere. The next time you see a doomsday headline, remember the progress we've made. For the first time in Earth's history, a species has the foresight to see a threat coming and the technical ability to prevent it.